So let's create our first full-fledged Unity project. So in your Unity projects folder, I'd like you to make a new folder, and we're going to call this Cube Spawner. Okay, and Cube Spawner is going to be empty. There's nothing in it, but we'll be putting something in shortly. So now open Unity. We're going to make a new project. We're going to place it in our Cube Spawner folder. Then just create the project. We don't need to import anything at the moment. An important concept in Unity is a scene. So you can think of scene as something like a level or a place to transition to. And the first thing you always want to do is save your scene. So we're going to call this scene 1. I want you to notice everything that's going on in the project. So right now in the hierarchy, the only game we have right now is a main camera. And the purpose of the main camera is to display what's happening in our project. The game screen indicates what the main camera is looking at, and the main camera is going to determine the perspective of the user of the program, the game or the simulation, whatever we're making. By default, the position is 0 on the x-axis, 1 on the y-axis, and -10 on the z-axis. Periodically, we might want to change this, but by default, we should generally not move the main camera, or try not to move the main camera. Okay, and then in our project, we have one asset, which is our first scene called Scene 1. Let's add another game object to the world. So remember that the game object is sort of the overarching, idea of like everything that goes into a scene is really just a game object. So we're going to go to game object, create other, and we're going to create a cube. So notice that when we did that, a cube appears in the screen. Notice that it was rendered in two different places. So we have one cube in the scene folder, and this is really where we're going to be doing a lot of our editing. We have a cube, we kind of looks like a square, just kind of a two-dimensional projection of the cube in the game pane. So in the scene pane, we have a model of the entire cube, and then in the game pane, we see how this would be displayed to the user of a program. And it's placed by default at position 0, 0, 0. And we're going to explore different aspects of it. So I'd like you to take a look over at the inspector pane. So for every game object has what's called components. So for example, the components of cube currently are transform, mesh filter, the cube mesh filter, a box collider, and a mesh renderer. So the transform component is arguably one of the most important ones that we'll be discussing. Transform has 3 different parts: position, rotation, and scale. Now, anytime we want to move an object or we want to change its size, position, rotation, and scale will be affected. So the first thing I want you to notice is that when we first created this game object, it has these 3 arrows jutting out of this 3 sides of it. And each of these arrows represents a different axis. So for example, let's take the green arrow and watch what happens to the Y component of position. So you can see that as we drag the cube up, the Y component of position increases. And when we drag it down, the Y value of position decreases. So to get it back to 0, you can actually just get rid of that. Just type 0, just goes automatically back. When we take the red arrow, this moves the cube along the x-axis. So the value for x is increasing. Now it's decreasing. Once again, type 0 to get rid of that. And for Z, this changes depth. That's the blue arrow. We can left click and drag, move towards the camera, move away from the camera. Once again, type 0. So Unity has something called gizmos, and this is the position gizmo. Now to switch out of the position gizmo and let's to the rotation gizmo, press E. Sorry. So to transition out of the position gizmo and into the rotation gizmo, press E. And you'll notice now that instead of having arrows, we have a sphere with 3 different circles along the surface. So if you click any of these, you should notice what changes. So I'll reset these to 0 again. So clicking on the green arrow and moving it around changes the Y value, and it rotates the cube around the Y axis. Manipulating the blue circle rotates the cube around the X axis. And manipulating the blue arrow rotates the cube around the Z axis, the depth axis. Okay. 0. And by the way, you can press tab and this will automatically take you into the next box. And the last transform component that we're going to be looking at is scale. So click on the cube and press R, and this is the scale gizmo. So right click on each, or left click on each of them and just see what they do. And you'll see that it essentially increases the size of the cube along a particular axis. So for example, clicking the red line allows you to increase the size and scale of the cube along the x-axis. The green arrow, this allows you to increase it along the y-axis, and the Z allows you to increase it along the z-axis. And these are called gizmos. To switch back to position, W, rotation E, scale is R. And there's rumored to be a new transform component in the newest version of Unity, but we don't know what that is yet. So possibly we'll explore that in the future. So the next component I want you to look at is the mesh filter. Okay, so first, before we do anything else, go ahead and just change the scale of everything back to 1. The next component I want to look at is the mesh filter. So something to keep in mind about 3D objects is that 3D objects are really just comprised of a bunch of tiny triangles. 3D models are made of something called a mesh. 3D models in games are generally a surface, and they're just hollow inside. There's no reason to have any more data inside of an object than you need. It wouldn't really make any sense. So imagine an egg that's just an eggshell, and it doesn't actually have any yolk inside. So in the case of the cube, the mesh filter is using a simple 3D cube model that's built into Unity. But you can also import a lot more complex 3D models, and in the future when we start actually creating our own 3D models, we can import those. But we'll talk about meshes a whole lot more later. It's a very important concept in 3D game development. So the next component we're going to look at is the box collider. And the collider component enables game objects to interact with other objects using the Unity physics engine. And let me just mention that the Unity physics engine is a fairly complex and accurate tool for development. This is what makes Unity very useful for doing things, not only just games, but for simulations, scientific experiments, for engineering, architecture, for military experiments. Unity is a pretty multifaceted engine and can be used for a lot of things. And a lot of that has to do with the physics engine that's built in. So there are several kinds of colliders that you can have. So you can have a sphere collider, a capsule, a box, and a mesh collider. And those are kind of in order of increasing computational complexity. So as you change the type of collider you have, the more calculations that need to be done. But think of a collider as, you might have also heard the term hitbox, and this is something in a video game. It tells you at what point you collide or make contact with an object inside of a game. So a lot of times the mesh is going to be different than the collider. If you make a collider that's completely form-fitting to the mesh, then you could really end up with something that's very complex, and a lot more complex than you might want. So having some sort of a simpler collider can really make calculations a lot speedier. So once again, we'll be talking about this quite a bit more later. Finally, the mesh renderer is really just what renders this 3D game object onto a screen. So it kind of creates this, that's what's actually creating this projection down here. So I want to add one more component to our cube. So we're going to go to Component, Physics, and we're going to add Rigid Body. And what this does, it's going to include physical forces like gravity, friction, collisions, and drag. And a rigid body enables a game object with a collider to move through space. Without a rigid body, even if the game object is moved by adjusting its transform component, the collider component of the game object will not actually move. And clearly that's really something that we want, because we want the object to be able to collide with other game objects. Okay, so let's go ahead and make a prefab for this cube. And what that means is a prefab is just a reusable element in a project that can be instantiated or cloned into existence any number of times. So you can think of a prefab as a mold for a game object, and think about it like a lot. What if we want to, if we have a game that's spawning 100 attacking goblins, we don't want to have to create 100 separate goblins and code them all or position them all. Sometimes it's just useful to have a single model that has the behavior that we want. So let's go ahead and create a prefab for this cube. So to do that, we're going to take cube in hierarchy and just drag it over to project, and automatically it creates a prefab for you. So you'll notice now that cube is now blue text, and this indicates that there is a prefab model for this object. One more thing that I want to add to this project is a directional light. So go to Game Object, Create Other, and go to Directional Light. So you'll notice now that in the game pane, this rendering of our cube is now bright and has color and texture and shadow, and the light allows us to do this. So we'll play with light a whole lot more later. So let's actually so right now if we press play, because we added physics to the cube, you'll notice that it drops. So it's dropping relative to gravity. Something else that's kind of cool is if you notice, you can actually calculate this. This is using negative 9.8 meters per second squared as the acceleration of gravity, which is something you may have covered in a physics course. And you can actually it actually uses that as to determine values. So let's actually make our project do something. So go to Create in the project folder, create C# script, and we're going to call this cube spawn. And essentially with it, and double click it to open it. And essentially what this is going to do is going to allow us to spawn a ton of cubes on the screen. And it's going to be really fun. So inside here, create an instance variable called public with a modifier public, and it's going to be a game object, and we're going to call it cube prefab variable. Then in start, place a call to the instantiate method, passing cube prefab variable as a parameter. We can press Control S to save, go back to your Unity page, and you'll notice that it has updated. If we press play, well, nothing different happens. And that's because we haven't changed something very important. So, for one, we need to take this cube and attach it to the main camera. So we haven't done that yet, so there's nothing attached to it, so nothing's going to happen. So now if we go to main camera, in the inspector, there's a new component of main camera called the cube spawn script. And you'll notice that there is essentially a link to the script, like a reference to the script called cube spawn. We don't want to change that. But then there's also this cube prefab variable. And that's that variable that we actually put into our code. That's this part. This public game object cube prefab variable, that's corresponding to this. Putting the public modifier in front of it makes it so that we can edit the value of the game object outside of the script itself. This is very useful. So what we're going to do is we're going to take this cube, this prefab cube, and drag it in here where it says none game object. So now cube prefab variable is going to have a value of our prefab cube. So let's see what happens. We press play, and it just spawns another cube. That's kind of cool. So it just falls to the ground. Neat. Alright, so the next thing I want you to do is go back to your script, and we're going to edit the script again. This time, we're just going to take that instantiate line, and we're going to copy and paste it into the update method. So now instead of a new cube prefab variable being called during initialization of the project, it's actually going to be called once per frame. So I think you might have an idea of what this could look like. So for the full effect, go ahead and push all of these other windows to the side and make your scene and game panes as large as you can. Zoom out a little bit and press play. So this is what happens when you spawn a cube every second. So you can see this should really demonstrate the power and the ability to handle complexity that the Unity engine has. This is a pretty sophisticated piece of software. Think about how many cubes and how many pieces of data are being rendered right now. And you can even see in the hierarchy, there are just countless numbers of clones of the cube. So it's pretty cool. Now, just maybe we'll add one more thing before we're done. So go ahead, go to Game Object, Create Other, and Cube. So we're going to create one more cube, and we're going to rename cube. We're going to call it Ground. So let's change some values of ground. In transform, change its position from to 0, -4, 0. Then change its scale to 10, 1, 10. So you'll notice now that we have something that kind of resembles a ground. Well, let's actually change it to something a little larger than that. Make it 41, 40. Make a very large platform. And let's see what happens. So now this ground will actually start catching all of the excess cubes. So that's our first Unity project. So next time we're going to learn a lot more about C# scripting, and we're going to make our cube spawner project a bit more interesting. So hope you enjoyed it, and I'll see you next time.